share my board. Let me quickly make reference to what we did last week. I could remember last week we talked about this syllabus brief for the JAMB exam. And I could remember I shared, just like I want to do now, I shared my syllabus that we're going to start from number basis. That's just the starting point for easy growth. So the number basis operations strictly from base 2 to 10, JAMB syllabus, strictly from base 2 to 10, and is under numbers and numeration. After that, we can now go to fraction, decimal approximation, and percentages, and then indices and logarithms and such. So today now, I've prepared some questions under sort that, under number basis actually, that I'm going to be giving past questions from JAMB, So I'm going to be writing them. Some of it I may just project directly on because I will be snapping it from a particular book. The soft copy is not available now, but I can get the soft copy, of course, later. If you have your past question and answer for JAMB, I'll be making reference to some particular years of exam where you will see question on number basis. I could remember basically that I said that conversion from base 2, conversion from base 10 to other bases. I mentioned binary, I mentioned octals, and I mentioned denary. Those are the bases we'll be interacting with. For now, JAMB has not actually told us to go as far as hexadecimal systems when you'll be talking about base 16 systems. So JAMB is not including that yet. I have not seen that update. So if that update comes, of course, it's nothing to worry about. But the basic thing we should know that if you are converting from base 2 or any other base to base 10, it's easy. You use indicial arrangement, indices. So let me start from that. From other bases to base 10, then from base 10 to other bases, we use factoring method. So from other bases to base 10 now, you are going to use indices arrangement. Indices arrangement in the sense that if you are given a question like, I want to talk about number basis now. Okay. We are converting from other bases to base 10. And don't forget that it's only from base 2. There's no base 1. In the numbering system, there's nothing like base 1. The lowest or the least base you can have is base 2. So in that base 2, the only existing numbers in base 2 are 0 and 1. And it grows continuously like that. I was able to show a table last week that shows the trend of how those things go. So I will not dwell on that much. I just want to start from conversion now. So conversion. So when we are converting from other bases to base 10, that's what we want to do now. From other bases to base 10. So let's assume we want to convert a number from base 3 to base 10. Let's say we have 1, 2, 1, base 3. I've told you last week that you have two methods. It's either you write your 3 as a subscript, of course, in number. You can also write it as a subscript in words. So if I don't want to write this 3 in number, I can just write it in words. Okay, 3. All right. I decide to encourage students to be writing in words because the way some students write, anyway, this is CBT exams now. Gone are the days when you need to write pencil and paper and then it has to be OBJ and you shade. Now it is basically CBT. But in the mode of calculation, if you want to do rough work too, you might be confused. writing numbers and bases together, you might get confused. So I encourage you to write in words so that it will be easier for you to identify that this is base you're talking about. So the base 3 now, this 3 now, I'm going to use it in an arrangement. I want to convert this number to base 10. So it's going to be 1 times 3 plus 2 times 3 plus 1 times 3. Now, each of the numbers that are contained in the original number that I want to put from base 3 to base 10 are 1, 2, and 1. While the 3 serves the base, these 3, each of these 3 are the base 3 I'm talking about. But I'm going to raise them to a power in order, starting from the last number, starting from my right hand side. And then I'm going to progress to my left hand side. So the first 3 will carry a power of 0. The second 3 will carry a power of 1. I'm progressing. All right. And then the next 3 will carry a power of 2. So when you have it in this format, you are done. The next thing is to evaluate each of these numbers you are going to have. And by that evaluation, of course, I'm going to have 1 times 3 raised to power 2 will give me 9. That plus 2 raised to power 3 raised to power 1 will give me 3, of course. And then plus 1, 3 raised to power 0. Anything raised to power 0 is always 1. So now 1 times 9 will give me 9. 2 times 3 will give me 6. And then 1 times 1 will give me 1. So by the time I add all of these together, I'm going to have 16. And that will now be in base 10. So the number that I have now is a base 10 number. Let me do away with that. The number that I have now is a base 10 number. So this answer now is a base 10 answer. So 121 in base 3 will give me 16 in base 10. 121 in base 3 will give me 16 in base 10. And this is the same procedure you will follow anytime you want to convert from other bases to base 10. From other bases to base 10. I just needed to establish this fact at this level because there are some questions that comes with it that are not this direct. And that is why I'm trying to lay these bases. It will work for any number that is not in base 10, but you want to bring that number to base 10. So I'm going to be setting an example now. Let me pick a question here. Okay. X in base 10 is equal to 23 in base 5. So we are looking for the value of X. So let me write that on the board. So I will call this one example 2 because I started with example. So X in base 10, this is the way it was written in question. Because it was typed, it's easy to put that in number. 23 in base 5. So we are to find X. If X in base 10 is equal to 23 in base 5, we are to find the value of X. So to find the value of X simply means we are converting from base 5 to base 10. There's a number in base 10 they want us to get, and that number is equal to 23 in base 5. So they want us to get the value of that. So the same way I converted earlier is just what I'm going to do here. So my 2 will be multiplied by 5, and I'm going to add that to 3 be multiplied by 5. And don't forget why we are multiplying by 5 is because 5 is the base, but we are taking it from that 5 to base 10. Now, starting from my far right hand side, I'm going to start with a power of 0. So this one will carry a power of 0. This one will carry a power of 1. And that's all we have. That's all the 5 we have in that. So we'll stop there. I did mean we have more numbers. We'll continue like that until we reach the last 5 in the far left hand side. So this one now will give you 5 raised to power 1, of course, is 5. So 2 times 5 will be 10. So I can just write it as 2 times 5 plus 3 times. I've said x 0 is 1. Some students get carried away when they see a big number raised to power 0. It has nothing to do with the size of the number. Once it's to power 0, it is automatically, and this will help you by the time you get to indices. All these facts will help you. So 2 times 5 gives you 10, and then 3 times 1 gives you 3. So 10 plus 3 will give you 13. So that means 13 base 10. That means x is equal to 13. X is equal to 13. And this is question number 43, 2016. JAMB, question number 43, 2016. You may not have that type because I know they used to use different question type, maybe type Q, type whatever. But at least it is a question in 2016 exam. I'm very sure of that. All right, so you have that. We can pick another one. Okay, this is a nice one. And maybe we should quickly just talk about it without wasting time. Okay, so let me do it this way. I'm going to quickly show you how to convert from base 10 to other bases so that we can get more advanced question as we have it here. So there will not be any form of a restriction. And I hope we'll be able to get that done in no time. So let's keep this handy and move to another new board. Okay, so conversion from base 10 to other bases. From base 10 to other bases. Now we are converting from base 10 to other bases. So from base 10 to other bases. To other bases. Okay, to other bases. From base 10 to other bases. You are going to be using what I call the factor division method. Factor division method. So let's assume there is a number. We can use the previous questions we used just to be sure that we have done the right thing. We can decide to use one of the questions we have used earlier. Maybe we start from here. 16 in base 10. Let's see if we convert this 16 in base 10 to a number in base 3. Are we going to get what we had actually had earlier? We can check that. We can actually check that. 16 in base 10. Let's see. 16 in base 10 to a number in base 3. This is how you do that. You draw a kind of diagram that looks like a division factor. So you write your 16 here, you put the base here. So this is base 3, this is 16. So I'm going to use 3 to divide 16 repeatedly. So 3 and 16, of course, we did a bit of this last week, so you can still quickly recall that. 3 and 16 will give you 5, and there will be a remainder of 1. I told you to always keep the remainder, all right? We need it handy. 3 and 5, you can only get it once, and now there will be a remainder of 2. And then, of course, 3 in 1 is not possible, so you write your 0 there, and then you keep a remainder of 1. Now, starting from the last number, and then you progress upwards. So you are going to list each of the remainders. Our main answer should be each of these remainders. This is what we need. We don't need all the division factors. We don't need all the factors. We need the remainder. So we are going to keep the remainder in that order, starting from the lowest. Starting from the last number we got, which is 1, 2, 1. And in base 3, of course, that was where we started from. So it shows that we've done the right thing. So converting 16 in base 10 to a number in base 3 is what gives us 1 to 1 in base 3. And of course, we can also check another one. We just did for base 5. Let us check whether it will work too for base 5. All right, so we have that here. We got 13 in base 10. If we convert this number to a number in base 5, what will it give us? Let us try it. 13 in base 10, we want to reverse the process, but we are not going to go this way. And I'm going to tell you something I told you last week quickly because of time. Let's quickly go 13 base 10. So if you have 13 in base 10, we want to convert it to a number in base 5. We use that same method. 13 will be here, and then our 5 will take this side. So the number of 5 we'll find in 13 is just 2, and there will be a remainder of 3. And then, of course, by the time you put 5 here to divide 2, 5 cannot go, so you write 0, and then you put a remainder of 2 here. So what we are interested in is this remainder, starting from the last number, that is 2. So we are going to write it in that order, proceeding until we get to the last one, now, which is 2 and 3, and those are the only 2 remainders we have. So it's going to be 2 3 base 5, of course, which was where we started from when we wanted to convert. So 23 in base 5 is what 13 in base 10 will give us. You remember that I gave you something sometimes ago. I don't know if that will work for you, but this is what I want to do. Let's quickly check this question. Let's quickly check this question. A very interesting one. Okay. 2p3 base 5 is equal to 7 base 8. I'm interested in this, and I want to quickly show you something by that, because there is a cross-referencing around it. If you are converting, there is a rule of conversion that is not common that I want to give you now. A rule of conversion that is not common that I want to give you. Consider a house that is sealed, a house that is sealed up, no way out, no way in. You can go within the house. Every mathematician is a constructor, or let me say construction agent. Okay, can do this. Okay, and I can do this. So we have this, and I can do the same here. I can do the same here. Okay, I can extend this in a way, make my drawing, and okay. So let me call this one 2, let me call this one 3, let me call this one 4, and this one 5. This will be 6. I have 7 here. I can call this 8, and I can call this 9. Then there is a passageway, of course, that is obvious. I can call it 10. So each of these are rooms in an enclosed house, no way out, no way in. So each of these rooms are like the number bases from 2 to 10. And then we have a passageway, which is 10 itself. So if you must move from any of the room to another room, you can't jump. You can only pass through the passage. So if I want to move from 6 to 7, from room 6 to 7, of course, I will have to go out of 6 and get into the passageway, which is 10. So I have options, but because I'm going to 7, I will just concentrate here, and then I'm moving from base 6 to 7. So it's not about like I can just move directly from 6 to 7 without passing through the passage. What does that mean? It means if you must convert from one base to another, the first thing is, the procedure is, you need to convert from that base to base 10 first. And then from base 10, you now convert to base 7. That's just the logic of this diagram. If I must convert from base 2 to base 5, it means that I must first convert from base 2 to base 10. Once I get to base 10, then I can now proceed and convert to base 5. There is no direct method that you can use to convert from base 2 to base 5. There is no direct method. You can only pass through base 10. And that is the logic here. So we're going to quickly employ that in solving this question. They want us to solve this 2q, and that is in base 5. Base 5, I will just write it as a small number. And they said that it is equal to 77 in base 8. In base 8. Now, they want us to find the value of q. They want us to find the value of q in base 5. So if you want to find the value of q in base 5, the first thing you need to do, you need to equate both of them at the level ground where they should be equal for real. and there is no other place where they can be equal for real, if not that you convert both to base 10. You need to convert both of them to base 10. All right. So if you convert both to base 10, then you'll be able to solve for the value of Q directly. Another method is you can concentrate only on this 77 base 8, convert it to base 10 first, then convert it to base 5. By the time you convert it to base 5, you can pick directly by comparing the value of your Q without wasting time. So any of those two options are available to us. So let me explore the second one first, then we'll come back and use the first method. Everything will still be equal at the end of the day. So I want to concentrate on 77 base 8. I'll convert it to base 10 first. Then I will now convert my answer to base 5. So to convert this to base 10, so converting this to base 10 will be 7 times 8 plus 7 times 8. I'm converting to base 10. So this one will carry a power of 0. And this 8 will carry a power of 1. So you now have 7 times 8 plus 7 times 1. That's what you have, because 8 raised to power 0 is 1. So when you do 7 multiplied by 8, you will get 56. So I have 56 plus 7. 7 times 1 will give you 7. So let me use another slide so that we can get our answer. So 56 plus 7 will give you, is anybody want to answer that? 56 plus 7, that's a very easy calculation to do. Let me not just waste time. 63. So you have 63 in base 10. That's an arrival. 63 in base 10. Now we want to convert this, forget, and bring it back to let you see where we are coming from. We are coming from 2Q3 in base 5. So by the time we converted this 77 base 8 to base 10, we were able to get 63 in base 10. Okay, that's what we got, 63 in base 10. We want to convert this 63 in base 10, we want to convert it back to base 5. All right, so our 63 in base 10 to base 5 will now give us this. You have 63 here, and then you have your 5 here. 5 in 63 will give you 12. You have 12, remainder of 3. 5 in 12 will give you 2, and there'll be a remainder of 2, because 5 times 2 is 10. 10 plus 2 is 5. And then 5 again, of course, in 2, 5 cannot go in 2, so you have to write a 0, and then you bring a remainder of 2. So at the end of the day, what you have is 2, 2, 3. Don't forget how our 2, 2, 3 is arrived at. We arrived at it by starting from the lowest last number here, and then we are going upward in base 5. So when you go back to the original question, that they gave us 2Q3 in base 5, but our 77 base 8, we are able to get 223. So let us now see what is happening. So we now have 2Q3 in base 5, of course, and that is now 223 in base 5. From what we can see, it is obvious. We can pick the value of our Q, which is the center number, and our Q is just 2. All right? So that makes sense in a way, of course. It makes sense. If you don't want to do this, there's another method. If you don't want to do this. So another method, let me use the word or, so that we can quickly, I will just direct you to the next page. Or, so we are going to solve another method now. 2Q3 in base 5, 77 base 8. We are going to solve it the other way around. So you have 2Q3 base 5 is equal to 77 in base 8. So I'm going to compare the two side by side, and I'm going to convert both sides to base 10 directly. So which means I'm going to have 2 times 5 plus Q times 5 plus 3 times 5. All right. and that will be equal to 7 times 8. I'm converting both sides to base 10 plus 7 times 8. Don't forget, each of them are different on their own. So I'm going to use 0 here, 1 here, and here I'm going to be using 0, 1, and 2. All right. So here you are going to have 2 times 5 square will give you 25.